Yeah, so it's my first time actually at a Halifax meetup. I went to Dal. I lived in Halifax for a bit, moved to Toronto. Now I'm back in Halifax. I'm excited to be here and be part of this community. And the reason I'm speaking here today, or how kind of this whole story started, is that when I first joined the Halifax Slack channel, I said, hey, anyone out there, or anyone out here, I guess, programming in Elixir or Erlang, and I got a couple responses, and then some people indicated that they'd be interested in learning a little bit more about it. So here I am today to tell you a little bit more about it. But when I volunteered myself for that talk, I didn't know too much about the format, or didn't think too much about how to introduce kind of a whole programming language in 25 minutes. So instead of doing kind of an introduction to Elixir, what this is going to be is more of an Elixir teaser. I'm going to focus on just like one or two things about Elixir, but not really introduce too much code, and look more at the runtime environment that makes Elixir and Erlang kind of unique and interesting to me and enjoyable to work with. So a little bit about me. Yes, I'm an Elixir enthusiast, and I work at PagerDuty, where we do a lot of Elixir. We've been an Elixir first company, I guess, for 3 years now, probably. And we have some great people working there with us that just know a lot about Elixir, and I learn a lot from them and have a good time working there. And in my spare time, I like skiing and mountain biking and Formula One. So if anyone wants to chat about those things, I'm also interested in those topics as well. And right, I'm not going to really introduce too much code, but I do want to cover a couple high-level things about what Elixir is, so that if you like this talk and want to go learn more about it on your own, you'll know a little bit what we're getting yourself into. So kind of most importantly, Elixir is a functional programming language. It's not a pure functional programming language like Haskell. There are definitely some trade-offs that have been made to make it a little more easier to develop in. You don't have to worry too much about what a nomad is or anything like that. And secondly, is that it's dynamically typed. If you're looking for a functional, strongly typed language, maybe Scala would be your thing. But again, I don't want to dwell too much on these things, because this is kind of not the coolest part about it, in my opinion. And I took these points straight off the Elixir website. And the third point they mentioned is that it's designed for scalability and maintainability, which seems like a bit of a bold claim and a little bit hand-wavy. So I want to explore those points a little more in the rest of this presentation. And speaking of the rest of this presentation, it's based really heavily off of this talk, which is one of my favorite talks ever, Elixir or Otherwise, by Mr. Urich. And he does a really good job of introducing kind of what Elixir and Erlang are kind of all about in a bit of a longer talk. So again, if you're interested in what I'm saying here today, I would encourage you to go watch this later. And I reached out to him a couple of days ago, just saying, hey, do you mind if I kind of follow your format a little bit, introduce some of the same concepts in the ways that you did? And he said, yeah, go for it for sure. So what we're going to see is based off of his talk a little bit. Okay, so we're going to go through a couple slides, then jump into a demo that's based off of some code that he wrote. And we're going to use that demo as a way to explore some of these concepts a little more in depth. So the concepts at hand are Elixir, of course, the title of this talk, Erlang, and the Beam. So again, Elixir is a programming language that's relatively new as far as programming languages go. And it's actually built on top of Erlang. They have kind of a Java Scala relationship, I guess. They each compile down to the same bytecode and then are executed on the Erlang Virtual Machine. So these are not compiled to like machine code like Go is, I guess. These run on a virtual machine, and that virtual machine is called the Beam. So even though we have Elixir, this relatively new programming language, its runtime environment is the Erlang Virtual Machine, which has been around for a very long time and is a very sturdy, battle-tested, all of those kind of buzzwords. So this talk could really be about Elixir and Erlang, but from here on out, I'm just going to say Elixir each time. And the central kind of building block of Elixir programs are processes. And each process is really simple. It just executes a bunch of code sequentially, top to bottom. Maybe have some functions running in there, but there's no fancy concurrent things happening. It's just single threaded isn't really the right word, but you can imagine it being single threaded, and you're just going to do one thing at a time. And these processes are a mechanism, like part of the runtime environment of the Erlang virtual machine. They're a first-class citizen. And they're not operating system processes, or don't get them confused with operating system threads either. These are things that are owned and run by the virtual machine itself. And they're very they're very lightweight. It's kind of what separates the Erlang virtual machine, the Beam, from some other paradigms and other virtual machines. And since these processes just execute things sequentially, if you want to have concurrency, which is one of the things that Elixir and Erlang are kind of a little bit famous for and what they enable us to do easily, if you want to have that kind of concurrency, what you need is two processes. You need to have two processes that are each, executing their own code. And to do that, you just spawn one process from another. There are a couple of different ways to do this. You can kind of configure this to start up when your application starts. You can do it on demand. And processes can spawn and be killed off, and they can die, and all sorts of things. The cool thing about these processes, and one thing that leads to really good error handling and high availability, is that they are completely independent from each other. Processes can monitor each other, and they can be linked to each other in some ways, but really they're operating completely independently. They are, in fact, so independent that they each have their own memory. They each have like their heap and their own stack, and they're even garbage collected independently, which lets you do some pretty cool things if you organize your code in such a way to take advantage of that. So what happens when we actually start, our Elixir service, our microservice in production? Well, the first thing is, of course, that the virtual machine needs to start. We need somewhere to run this thing. And then it's going to start bringing up all these processes. And a given, I'll just keep calling it microservice, can have many processes. They're extremely lightweight. Of course, if each process is doing a ton of really CPU heavy work, maybe you wouldn't want to have as many. But in general, they're very cheap to spawn and cheap to maintain. So the first set of processes we might bring up is the kind of core Elixir things, maybe IO stuff, the built-in logger, those kind of things that you really need to get your program to run. And then we might bring up some more processes, and these might be your actual application code, the things that are going to run your business logic and make your users happy. And then there might be even more processes, and these could come from dependencies that you include in your project. When you have an Elixir project, we have a package manager like npm and like all the other, it's easy to include packages and stuff like that. But one neat thing is that you don't really know, or you don't have to know or have to care whether the dependencies you're including are going to be processes, are going to run and be long living or not. For example, maybe you have a dependency that's just a bunch of math functions. That's probably not going to have any kind of long running process associated with it. You would just call those math functions in your application processes. But maybe you have another dependency that's helping you connect to like a relational database, and you want to have a long running connection open to that. That would probably be managed by some sort of process and be long living. But you don't have to worry about that. You just include the dependencies and interact with them like you would any other code. So now we have a bunch of processes here, and of course they need time. They need to be run. They need to be executed. And how that works is that the Beam has schedulers, and there's going to be one scheduler per CPU on the host machine. So in this example diagram here, the host machine would have 4 CPUs, and that would lead to us having 4 schedulers running on the Beam. Erlang historically was invented for like telephone networks and telephone switches and stuff like that, where they really prioritized high availability. So the schedulers, with that in mind, also prioritize high availability and work in sort of a round robin fashion. They will make sure that every process gets time to do whatever it wants to do, instead of giving special treatment to certain processes that are a little busier. So that way we maintain a high availability for all our processes and for our system to remain responsive. Okay, with that in mind, now it's time to hop into a little demo that's going to show off a little bit about processes and a little bit more about the runtime environment. So let me minimize this, and we'll get back to the slides in a little bit. Cool. So here we have, if I guess thumbs up, everyone can see some graphs and some white screens. Thank you, Matthew. Okay, so this is a really simple web application that's going to show off a little bit about these process primitives. On the left, this is my form. Very simple, but it kind of conveys what most forms do. We're going to take some user input, we're going to do something to it, and we're going to send it back to the user. And on the right, we have just a couple really simple graphs that are displaying kind of the usage on our system. And what this system does is it computes the summation of a given number. So if I say 3, it's going to be 1 + 2 + 3, that's 6. If I do 4, that's 10. 5 is 15. And that's all our system does, just computes some numbers. And to make things a little more interesting, I'm going to just start up a bunch of background jobs. And all these background jobs they are all individual processes. So we now have 10,000 more processes running than we had a little bit ago. And what each of them does is, well, when they spawn, they are going to sleep for a second, do some amount of CPU-bound work, then report that they've done this work to a process that is running all of this, that's gathering the metrics, and then go back to sleep for a second and do it all over again. So we're expecting to see around 10,000 of these successes every second. But their processes, like I mentioned earlier, they are completely independent, and we haven't taken any extra effort to synchronize these ones. So if you look closely, you'll see a little bit of variations kind of on this line here. Now, this system, like the systems I work on, like the systems you people work on, has some bugs. It has some edge cases we missed, and we prefer not to have them, but they exist, and that's unfortunate. So we're going to examine what happens when we encounter those as a user. And the first bug is that when I enter the number 13, I get an error. Something has gone wrong, cannot compute the summation of the number 13. Like any kind of web framework, one bad request didn't bring down the whole thing. I can still punch in other numbers and the system is still responsive. And it hasn't impacted any of these other processes that are going along either. We're still doing, 10,000 successful pointless processes every second there. And you're probably thinking, so what? Any half decent web framework will make sure that one request doesn't bring down the whole application. And that is true. The interesting thing is about how this is achieved in Elixir. There's no kind of try catch block. There's no top level error handler that's going to catch all these exceptions as they bubble up. This is done purely from just by organizing our processes in an intelligent way. And I'm going to flip back to the slides just to give a stupid Zoom taskbars in the way, just to give a little more information about the a little more information about the life cycle of one of these requests. So when our client, our browser, connects to the system, we establish a WebSocket connection. And that WebSocket connection is going to be owned and kind of facilitated by, of course, the process. And if we have multiple clients connecting to our system, each one of those is going to have a different process, a unique process assigned to it. Because like I said earlier, these processes are cheap. If we have a bunch of clients connected to the system and not doing anything, that's really not going to cost us anything in terms of resources. We could have, tens of thousands of these, no problem. And when the client submits some sort of input, like I submitted the number 4 and got back the number 10, what happens is that our connection process that owns that WebSocket, it's going to spawn another process that's going to do the math for us. So I'm labeling it the calculation process. And then it's going to do the function call. It's going to say calculate number 4. And it's going to get that information, respond back to the connection process. That's going to then respond back to the client. And this is the success case when everything goes well. And when that calculation process is done, it goes away. Processes can be long-lived. They can be very short. This one, it spawned, did a little bit of math, told us the answer, and then was killed off and removed from the system. This is also pretty cool because it means we didn't have to do any garbage collection. Of course, this process is very simple, but if you can organize your processes in such a way that they can be short-lived, then you don't have to stop everything to perform garbage collection, because when the process is killed and removed, then that's when the garbage collection can take place later on. So in the error scenario where I entered the number 13, similar thing is happening. Of course, we're spawning, we're handing some information to our calculation process. But our connection process is actually monitoring the calculation process. And monitoring on the Erlang Virtual Machine and in Elixir, we have monitoring and we have linking. I'm not going to get too much into linking is. That's more to do with supervision strategies and something I don't have time to go into. But monitoring is pretty much watching another process. So here we have our connection process watching the calculation process. And then it tries to perform the calculation, and it explodes. We get some sort of error. When that happens, the process dies, it disappears. And this time we have the virtual machine saying, hey, connection process, you were looking at this other process. Well, it died. And here's a little bit of information about that. Then when our connection process receives this information, it can do whatever we want to do with that. And in this case, we're just sending an error back to the client. And that's how we can achieve error handling without any kind of try catch blocks or any regular like control flow primitives. Back to the demo. Cool. Okay. So that's not too bad of an error anyway. You know, a small edge case like that might frustrate some users, but it's not harming our system at all. And it probably wouldn't harm many other systems either, because most web frameworks have decent isolation of errors on requests. But what happens if we have some kind of other worse errors? For example, what happens if I put in a really big number? So here we can see that we are calculating and our CPU usage has spiked, or the scheduler usage spiked, scheduling cycles on the CPU. So that's not so good. How many nines did I put in? A lot. Anyway, eventually this will come back down. Eventually it'll come back down. So this is a problem. Obviously, however my math has been implemented here is not great. Perhaps I did it recursively instead of using high school math where I would have learned the formula to easily compute the summation of a number. And this is not good, but at least our system is still responsive. I can still punch in other inputs and get answers back. All these other processes that are doing some sort of background work, they're still responsive and still making progress. Oh geez, I really put in too many nines there. Anyway, the point is that even when I put something large, it's going to take a lot of time, because the schedulers prioritize round robin and being fair to everything. All these other processes can still get their work done, and we can maintain a high availability on our system for all of the users. So that's kind of a little bit about scalability. Like spawning processes makes concurrent tasks really easy. It helps us tell a really nice story of parallelism, and it's easy to spin up background jobs and stuff in Elixir. But what about the maintainability? Like how is the system easier to maintain than some other system? And part of the answer to that is a lot of the tools that ship with Erlang completely built in that are going to help us debug some of these processes. So we're going to dive into those a little bit now. And I said we weren't going to do too much coding, but we have to do just a little bit of coding. So here, the code that's running this app is exactly how we would run it in production. You build what's called a release, and then you ship that release to your EC2 instance or whatever you want to do. So here I'm connecting to that. I've connected to that release, so now I want to poke around the code a little bit, which is a completely safe thing to do even in production. And the first thing I want to do is just list all the processes. Let me make that bigger for everyone. And this didn't return a whole lot of useful information. It just looks like a bunch of things called PID. And what a PID is a process ID. That is like a unique identifier for a given process. Of course, it makes sense that each process would have some sort of ID, but it's also important not just for our debugging, but for communicating between processes. If you've heard of an actor system for concurrency, as opposed to kind of Go channels or Java threads or anything like that, another school of thought for doing concurrent systems is using an actor system, where you have these different actors and they send messages to each other. And that's exactly what our Elixir processes are. Each of one of those, you could just call them an actor instead. And they run completely in isolation, like we've discussed before. And the only way they can communicate is by sending messages back and forth to each other. And when one process sends a message to another, what that's doing is actually just taking some message and putting it in the mailbox of another process. That receiving process is just going to work through its queue of mailboxes, like first in, first out, doing one at a time, processing things and responding back or not responding back, depending on what it needs to do. So if we just pluck the first process out of this list and get some more information about it, we can see that the virtual machine has some information to tell us about this process. There's some stuff about the garbage collection. There's some stuff about the memory, like its heap size and its stack size, like some useful debugging information. There's lots to dig into here, but the main thing we're interested in is this measurement called reductions. And reductions is kind of analogous to CPU time or CPU cycles. So if I go back to the browser, this is still up there. So we have some sort of process that is kind of running away with our CPU. So we'd be interested in finding basically taking all of these processes and sorting them by which one is using the most CPU, essentially. And of course, we can do that with the code. We basically just iterate over all of this and sort by the field that we're interested in, which is reductions. But we can also do that with another tool that ships with Erlang called Observer. Observer. And this tool has a pretty primitive user interface, but it uses a lot of the code that's just available to any Elixir program. And again, this is just built into Elixir. This is not like some dependency I've added. This is like one of the tools that ships, so you can help debug your systems running in production with no strings attached, pretty much. Oh, sorry. I think Zoom has made my UI quite slow, or my computer. Okay, well, while I wait for this to come around, pretty much what I've done here is I've started up just yet another little terminal for Elixir. And one of the other features of Elixir Erlang that people like is that there's by default or built in, there is distribution and like node discovery and load balancing, I guess you could also say. So if you have multiple computers all working together, they can all be running the same Elixir code. And then when you spawn a process, you don't have to worry about which one of those machines that process might go to. And if a process dies or a certain machine goes down, all of the work it was doing will be moved automatically to another machine. That helps give you, of course, some nice fault tolerance. What the heck is going on here? It's not going to make for a very interesting demo if I can't click this button up here.
Does it have anything to do with the amount of processes that you've put through, as Chris Admins suggested?
Oh, that's actually a good question. It very well might. Let's see. Let me just kill this off and start over again. Wasn't supposed to matter, but let's see. All right, let's crank this back up to 10,000 and pick up where we left off. Cool. Okay. So actually, what I meant to do was I have a special error case set up where I punch in -1, and that also pegs the CPU because my mathematical function was not expecting negative numbers, and now something's gone wrong. So let's try this again. So our system is running, and I want to start this observer. Good. There we go. Yes, it is more responsive now. Cool. Okay. So all I've done by clicking node is because now there's multiple nodes in my network, which I kind of glossed over big time, but I want to connect to the node that's doing all this work. One of the cool things we can see is all the different applications. I mentioned that there's lots of different processes started up and lots of things running. Well, here we have a list of things that are all being run. A lot of these things are dependencies I've loaded in. Phoenix here, this is my web framework that's powering the WebSockets and stuff like that. You can see that there's like the built-in logger. And then there we go. And then there's also my example system. So some of those processes we started show up here, and we don't need to, we're not going to dive into what all this is, but this is the supervision tree. You can kind of just imagine or take my word for it that when certain things die, parts of this tree will die off and then be respawned, like depending on what is happening in those processes. And in our case, this process here, I just know this because I wrote this code, but it's under the math. And this is one process that is doing all this math for us that's kind of hanging. And we can verify that by heading over to this list of processes, which is going to do the same thing. Oh, it's really slow too. This list of processes here is just a visual representation of what we already saw over here with this list of processes. And sorting by those reductions shows us that we have one process that is like by far doing way more CPU usage than any of the other ones. So what I can do is go ahead and just kill off that process. This can also be done in code, but it's just kind of easier from the UI. So I've killed that off. And now if we go back here, we can see that immediately the amount of CPU has come back down to earth because that one runaway process, which we were able to debug and find quite easily, has been handled. So of course, we'd want to make some changes to our code to address these issues, but at least it's just trying to show off that it's not so hard to debug these things in production because Erlang gives you a lot of tools to help facilitate this, even if you have thousands of processes running and stuff like that. Okay, back to the slide. Hopefully that was coherent enough, even with the lag. Cool. So that's kind of the primitives of Elixir as processes and building things with those. I'd really glossed over a lot of other cool parts like supervision trees and what to do when certain processes fail and how to restart from failure. And those are really well exemplified in Phoenix, which is the web framework that everyone uses, which is quite popular. and also another project called Nerves that is also extremely popular. Nerves is cool because lets you pretty much write Elixir code that goes on embedded in IoT devices. I think for a long time the story with those was embedded C code and stuff like that. But it makes sense that having some sort of supervision tree and fault tolerance with Elixir or the Erlang Virtual Machine would be really handy on these little IoT devices that you might have way out in the field that aren't always connected to the internet and can't receive patch updates. So this gives you a little bit more resilience for stuff like that. And I also just wanted to briefly mention some companies that use Elixir. I think there's a lot more than 5, but these are people that I know personally who work at these companies or who have met on the forums. Discord probably are like the coolest users of Elixir because they have a couple of blog posts that talk about how they handle all their traffic and how they have built a lot of stuff on Elixir. And I think the coolest part about that is that they have a team of 5 engineers that are responsible for the real-time chat that is all powered by Elixir. So that's obviously quite a multiplier effect. They have 5 people powering chat systems used by millions of people. And yeah, that's pretty much the end. Hopefully this was a little bit coherent. I figured this would be a little more interesting than just showing code example after code example and how to define a function and those kind of things. So if you are interested in learning any more about Elixir, you can reach out to me on the HalloHacks Slack. Yeah, I guess that's it. Are there any questions now?
All right, thanks, Tyler. Opening the floor.
I just thought I'd mention, I noticed the white text on the white background in your process inspector thing. And I noticed in an app I was using this week that's from night mode, and in a hop, it caused the whole UI to just be entirely broken because you couldn't see any of the elements on the UI buttons.
Oh, thanks. Yeah, that's good to know. Actually, I noticed that, yeah, my little UI inspector kind of broke in that way a couple of weeks ago. I didn't know why, and I think that was right around the time that I upgraded my operating system and switched to night mode. So thank you for pointing that out, Matt.
Hey, Tyler, I want to say great talk, man. You made me want to try out Elixir. Even though I haven't seen any code, I think I'm going to go look some up. So my question is, you mentioned Discord and how they used it. Can you give like other examples where using Elixir for a project would be a good idea?
For sure. Yeah, maybe I'll start by giving some examples of when using Elixir is a bad idea, just so I don't come off as too biased. It's not, if you need like the ultimate like performance, like you're writing some, I don't know, like shader or something, or some code that runs on a GPU, that is not what like Elixir is all about. It really is about high availability. So it really is, I mean, I feel like a lot of programming languages say that they're really good for web servers and stuff like that. But at our company, we had some code written in Scala and even more code written in Ruby on Rails. And we've been slowly moving that over to Elixir and finding that it runs the same, it can handle the same amount of traffic with like much less like resources used. And really just writing concurrent code just becomes so much easier. When we used to do Ruby on Rails and you want to have some background jobs, you'd reach for some sort of plugin, probably powered by Redis or something like that. And then you'd want to have some other long running jobs. You'd have to have some sort of other plugin or other system for that. And you put Nginx in front of all that stuff. All of that can just be done in Elixir. Like we can have one app that just handles all that, like a single code base, or at least a single programming language that enables all those things. Like spawning processes is just so easy to spawn background jobs and have them report back to you when it's all done. I think it's really good for that kind of work. Elixir was actually created by a guy, a Brazilian guy named Jose, and he was on the Ruby on Rails core team, and he basically created it out of a need for more concurrent programmer. He thought that some of the models there were just not serving his needs well enough, or he was having to reach for way too many third-party things and it was becoming hard to manage. He kind of thought Erlang looked like a good idea, but didn't love like the programming ergonomics of Erlang. It's kind of weird and funky looking. So that's how kind of a little bit how Elixir was actually born.
Awesome, thanks.
Tyler, I have a question. How is like Elixir whole like, third party like extension environment? Because like frameworks usually they're as strong as like, plugin libraries you can include. Like how is the library like availability looks like?
That's a really good question. And the honest answer is that it's mediocre. Because Elixir and Erlang like compile down to the same bytecode, you can use any Erlang dependency in Elixir and vice versa. So that's really good. But a lot of Erlang code is old, not in a bad way, but if you're looking for like SSL libraries or HTTP libraries, like yeah, you could find those in Erlang, no problem. But if you're looking for kind of newer stuff, like maybe say like a Kafka library, that kind of thing might be a little bit easier to find in Elixir, just because now there's more people are writing Elixir code, and a lot of these Elixir libraries are a little bit young. I'd say any of the core, like this is not a big problem we face at work. There are certain libraries where we've had to submit PRs back upstream to fix bugs that we found. But nothing too crazy. I would say it probably depends on your domain. And if you're doing something that's fairly specialized, maybe check to see if there are some good libraries for that in Elixir or Erlang before jumping ship. But if you're doing like data processing or stream processing or web servers or that kind of stuff, I think it's a good choice, and there's lots of good support out there.
Thank you.
I got a question. I know like just hearing about Elixir, there's kind of like the idea of the processes, and they seems like kind of like, you can kind of let it die and it'll come back up. Like a lot of that kind of workload thing sounds like kind of like what you get with Kubernetes. So I'm wondering like, how would you do that from like a DevOps perspective of having applications running in that, where you're kind of letting it die, where Kubernetes, it's kind of ephemeral. You let the container die and then you spin up another one. Do you kind of still do that, but then have the Erlang VM kind of handling all these processes in there?
Yeah, that's a really good question. And Erlang definitely came in a time before we had all these containerized systems and stuff like that. There's actually one really cool feature of Erlang and Elixir that we have never used, and that is performing a hot code reload. So pretty much what that means is you can have code running on a server and you can update that code without bringing the system down. Again, because Erlang was all about high availability and like zero downtime. And pretty much how that works is that these processes all have their state. So when you want to deploy this hot code reload, you just tell it, if necessary, how to map the existing state to the new state, and then the process will just kind of keep running from there. Unfortunately, this mechanism is extremely hard to pull off in like a containerized, like somewhat stateless environment where, we have these Elixir processes that are just running it on a container and don't really care too much about what else is running around them. For our personal setup, like at my work, pretty much what we do is, yes, we still let it die in Elixir and have our supervision strategy set up. Oftentimes, we will tailor kind of the top level supervisor to be a little bit more lenient, because we know we have our container orchestrator that will restart everything. An example of that is that we might, if we have some Elixir service that is depending, on an external MySQL database or Kafka cluster, something like that, and it's having trouble connecting, we might make it retry a couple times in quick succession, and then let the whole thing die and let the container orchestrator bump it onto a different machine in hopes that maybe it was some sort of networking error between those two machines that's causing the errors. So it kind of, you can customize these supervision trees, which again, I didn't talk about at all in my presentation, but it was another really cool part about all of this, to your domain. Maybe you are, more lenient with some sort of fire and forget requests. You don't care if they fail too much, but being able to connect to your primary data store is obviously completely critical for your application. So depending on what you want to do, you're going to tailor your tolerance to that level. And then if nothing's really working, and then we let that bubble up to the orchestrator and let it just restart the whole thing.
Cool, thanks.
Yeah, I got a quick question there. How does it handle like passing data between processes? Is it like completely like independent, or is there like some kind of like mutex syntax built in, or maybe it's like the structure of the language is such that that mutexes are handled without you having to actually write them or something like that?
Cool. Yeah, so that's one of the big advantages of going with an actor system, is that you because each individual process is completely isolated and completely sequential on the inside, and it's just doing things kind of one at a time. So if I was a process and all of you were sending me things to do, I would just be doing one of them at a time. And eventually I would get to every process in this mailbox, in my mailbox, execute whatever it was, and go from there. So mutexes, we don't, what am I trying to say here? There's a really succinct way to sum this up, but it's escaping me right now. But we don't really worry about locking kind of bits of data, because we just send the message to the process, giving it kind of everything it needs. In reality, the virtual machine is quite a lot smarter than that. If I was sending a megabyte of binary data to a process, it doesn't actually copy all of that and send it. There's like a pointer on like a globally shared like memory address, so that things can be passed more efficiently. But in summary, I would say that when you're programming concurrently with an active system, locking and mutexes isn't something you really have to worry about, which is awesome.
I have a question, two questions. That's cool. Yeah, so I'm beginner again, as I said in the last talk. And one thing that's important for me is that there's so many other languages that I can learn, and I'm trying to also get into employment opportunities in the future. And the first part of the question, my first question would be, what is like the adoption rate looking like for Elixir? Is it like the hottest new thing that you think there'll be some time that more and more companies are going to be implementing this, and therefore you learning this new skill would be important?
That's a good question. I think it really depends on who you ask. If you're deep into the hive mind on some of the Elixir forums, it is the only thing worth programming in, and everything else sucks. But if that's not the case, and I hope that I didn't convey it like that, because I think there's lots of other good reasons you'd pick other languages. Quite honestly, I have a lot of fun programming in this one because of the nature of the work we do. It is a good fit. In terms of adoption, I guess maybe a good place to look at that might be like those Stack Overflow surveys they do, which is just like a really big version of our Halihax one, kind of, where they just ask how many people are programming in a given language. Based on the conferences I've attended, it sounds like there are some big companies that are moving some stuff over, but I think the same thing could almost be said with any language. Like I guess it's hard to measure and hard to know. I mean, I think the future is bright. I'm continuing to learn and buy textbooks and educate myself. But I couldn't really answer that on any more of a bigger scale than that.
Okay, and just the other thing, I have a very preliminary knowledge of virtual machines, and I'm just wondering, when it comes to actual like consumers using your applications, like is this something that you can make an iPhone app with, or you could have more? I know that we're talking about web addressing, but I was curious if there's any other applications.
That's a really good question as well, actually. As far as I know, I haven't seen any projects where someone has tried to port it to that kind of device. There's kind of no reason it shouldn't be possible. I think the answer is that there might just be better tools for the job. The best example I have of that, again, is just that Nerves project that I super briefly mentioned, where they're targeting a lot of IoT devices. As far as I understand, because of that project, Elixir is becoming like a very popular language for Raspberry Pis for hobbyists, but then for like real IoT devices out in the field, like used by companies, because of some of the fault tolerance and high availability you get by setting up like a supervisor. So that, yeah, if you have some sensor, some computer out in the middle of nowhere measuring things, and there is some bug, like kind of like I demonstrated, hopefully it doesn't take down your whole system. And then if it does, hopefully it can just restart itself and come back up. So that's definitely becoming a popular use case for that. But in terms of phones and stuff, like I think if you wanted to become an Android dev, I'd probably tell you not to bother with Elixir or Erlang.
I guess it's not so much a question, but an observation. I know you mentioned earlier about like Rails, and I think I've seen something where a lot of people who used to be Ruby or Rails developers are like looking at Elixir and like Phoenix as like great places to go. Like, I think I don't know if I see a lot of similarities necessarily, like, but like, I think it's interesting because like, I don't see there being a lot of traction with that community anymore. And now like Elixir seems a lot faster, and I don't know, it seems popular in that group.
Yeah, I think so. I actually had no Ruby on Rails background before going to PagerDuty, where we have like quite a bit of Ruby on Rails code, but most of our new stuff is written in Elixir. And my observation on that is that the similarities between Ruby and Elixir, or I guess really specifically Ruby on Rails and the Phoenix web framework, are mostly superficial. Like if you knew how to, set up a controller, do some database queries and stuff like that in Ruby, you could be pretty productive pretty quickly in Elixir. But then when you want to do more complicated things in Elixir, hopefully those things become a lot easier. There was a really good keynote given once from I think it was the main creator of that Phoenix framework, and he just called it the pit of success, and how we want people who are new to the framework or the language to kind of just accidentally fall down the right path and make it easy to do the right thing, as opposed to doing the wrong thing, obviously. I think some examples of that are even just how our Elixir systems interact with databases. Like I know in Ruby, there's that active record, and it kind of extracts everything away, and you're maybe doing a lot of queries and you're doing, and that is just pretty much impossible to do in Elixir with the framework that is popular there called Ecto. And kind of other examples of that. So yeah, I know that a lot of people are making the switch over, because on the forums I see a lot of questions about like this is how I do this in a Ruby, how do I do it in Elixir, or what's the Elixir equivalent of this Ruby library? And a lot of times there's an answer. A lot of times the answer is that, like, not in a mean way, but like you shouldn't do it that way. Here's how you would approach it now in this functional language, or with doing it with processes and stuff like that.
Cool, thanks.